Hopefully everybody has had a chance to try doing the object examples on this slide. I'm going to do in this video a quick review of what you were supposed to see when you tried those examples and what they created. We've mentioned already that if you put text on a command line and surround it with quotes, that tells PowerShell to create a string object. If I create an object on the command line, whether that's by running a commandlet or simply doing something that makes PowerShell create an object, that object gets created. If I don't tell PowerShell what to do with the object, if I don't send it through a pipe or give it as data to a command, it just falls off the end of the command line. We said that when an object falls off the end of the command line, PowerShell will catch that object and display it using the default display. So when I put a string on the command line by itself, I'm creating an object and dropping it and letting PowerShell display it. So the string will display. We can do this with a number of different data types. The string is one of the obvious ones. Another obvious one is to make a number by simply entering something that looks like a number. That will cause PowerShell to create a number object. And if I don't tell PowerShell what to do with the object, it will come out on the screen in its default display. Looking like a number can be done in lots of different ways. Simple digits for something like an integer is fine. A negative number is fine. A decimal number is fine. A number in scientific notation is fine. Something that looks like a number and does not have quotes on it will be turned into some kind of number object. There are different number objects. A floating point number or decimal number is not the same as an integer as far as the kind of object created, but in either case they can be automatically created using the data on the command line. There is only one kind of string. The string object itself is the typical one that we use, and it's created by putting quotes around something. If I put quotes around something that looks like a number, the quotes take precedence and I get a string object. If I use the scientific notation again, it's pretty easy to see that what I've made this time is the string, not the number. When creating objects, if we put something on the command line like a string or a number by itself, we get a single object of an appropriate type to hold our data. If I wanted to create a collection of objects, more than one, I've actually done this already in previous examples without pointing it out, we put objects separated by commas. If I put a series of number objects separated by commas, I am creating one collection of objects. In this case, 5 objects in the collection, all integer numbers containing the values showing on my screen. If I press enter, the default display will be done because the object collection gets created and dropped off the end of the command line. It falls off the end. I didn't tell PowerShell what to do with the output, so the output comes out on the screen. One object per line. The objects in a collection do not all have to be the same kind of data. This will create a single collection. The collection will have 4 objects in it. The first 2 will be integers. The next 2 will be strings. If I don't tell PowerShell what to do with the collection of objects, it will fall off the end of the command line. PowerShell will catch it and do the default display on each object. Anything that can make an object on the command line can be used to create a collection this way. I can use the parentheses to tell PowerShell to run a commandlet, take whatever it produces, and put the output on the command line, which will be hopefully one or more objects. I can then use those in a collection I'm building. I can use them any way I wish that's valid for an object. In this case, I made a collection or array with 4 elements or objects in it. The first 2 were integers. The next one was a date-time object, which default displays as a formatted string of the current calendar date and 12-hour time. And the last object is the host object, the one that we used originally to see what version of PowerShell we were running. An object that represents the running PowerShell process, not the host computer. We can redirect the output of objects we create without having to have separate commandlets. If I create an object on the command line and use the redirection, the display that would have come out on the screen is instead sent to the file. And if I look in that file, I'll see the display output that I would have seen on my screen. It has been saved. This is true for any objects you wish to create on the command line. If you want to work with a collection as a single object to work with, you could put parentheses around it. It usually is not necessary. Many commandlets in PowerShell that can work on multiple objects expect that you will give them the multiple objects as a single collection. An example of that is the makedir command. We know that we can say makedir to make a directory by giving it an object. In this case, if we don't give it an object that happens to be a directory type object, we give it a string. Even if we don't put quotes on it, PowerShell assumes we meant to give it a string. We can be explicit about it if we want by putting quotes around it. At any rate, it's going to make a directory, and the name of the directory will be the string from the command line. If I wanted to make 2 directories in Bash or any of the traditional shells, I would say make dir A, space B, space C, space D, make as many as I wished. If I do this in PowerShell, I'm going to get an error that says there's something wrong with the B on that line. Notice it didn't complain about A, even though it should have, because I've already made a directory named A, and I should have gotten an error that says the A directory already exists. In other words, the command didn't work at all. Makedir can only take one object. That does not mean makedir can only make one directory at a time. Recall that an object may contain a single object, or it may contain a whole collection of objects. So if you want to make multiple directories with a command like to make directory, you give it a collection of names to make. String, comma, string, comma, string, comma, string. And then it will try to make them all. Another interesting thing to take note about, in traditional shells, if you ask a command to work on multiple things, multiple files for example, and some file it needs to work on doesn't exist, most commands will stop immediately with an error and not process anything further. PowerShell will keep going. So in this case, I told it to make a directory named A, directory named B, directory named C. The directory A already existed, so when it tried to make that one, it had an error. It did not stop. It continued on and made the B and C directories and created 2 objects in a collection to represent the B and C directories. And those 2 objects were the output of the makedir, which is why we have printed output. I didn't tell it what to do with the output objects from makedir, so it simply displayed them. So be careful with PowerShell. A command that is supposed to work on multiple items will not fail at the first thing that goes wrong. It may well fail and keep going with other things, in which case you can wind up with some very funny states and situations. Again, it is really important to test what you're trying to do, including testing when it doesn't work, so that when your script runs, you don't get surprises. Of course, the last thing on the example slide was an example of the out null command, which we've already seen. Hopefully this helps everybody understand that we can create objects on the command line. We can create collections of objects on the command line. And we can use those objects as data for commands, or we can use them to create objects to work with and do things with.